Very good afternoon, students. In this session, we are going to look at the properties of determinants. I have taken a sample determinant called delta. You can see the arrangements of the 9 numbers. The properties of determinants. So we will look into the 6 properties, and these properties help every student to evaluate easily. Number 1, simplify the evaluation, and most important of all, prove algebraic identities with the determinants. So you are expected to prove certain identities given in the form of determinant, the equivalent in the algebraic form. Well, the very first property, I have taken a sample determinant delta and property number 1. Shall I call it P1? Let us make it P1. The first property, even if you change the determinant, the conversion of rows into columns, columns into rows, what is that called? Everybody knows it is transpose. So not only matrix can be transposed, determinant also can be transposed. So let us first of all evaluate delta. Let us evaluate this delta, expanding by row 1, customary, cofactor 1 minus of minus 3, then there is minus of minus 1 plus 1, it's a minor 2 into 1, minus of minus 3 again, and add the third cofactor multiplied by 1, that is 2 minus 1. So it is 4 plus 5 plus 1. So it is 10. Now property 1 tells you the value delta is not altered, meaning the value 10 will remain 10 always when delta is transposed. Delta is transposed. What is the transpose? Let us take delta transpose. Delta transpose. So I am writing row 1, 1, minus 1, 1 in the form of column 1. 2, 1 and minus 3 which was in row 2 I am writing in column 2. The row 3 contains elements 1, 1, 1 which I am presenting in column 3. Let us evaluate once again, expanding by row 1. First element 1, cofactor 1 minus of minus 3, negative 2, okay, negative for the cofactor, and minor is minus 1, minus of 1 again, and plus adding 1 into the cofactor, 3 minus 1 into minus 3, that gives 3 minus of 1. That makes 4 plus 2. As you can see, the value has not changed. Delta transpose value, determinant value is same as determinant value delta. Both happen to be same as 10. That is the property P1. So I hope my writing is visible. Delta is not altered when delta is transposed. Okay. Property 2. The property 2, if any 2 rows in bracket or column are interchanged then the determinant value, the delta indicates the determinant value. Changes in sign only, which means magnitude will still be same, it changes in sign only. Earlier the value we see it was 10. Now try interchanging any two rows or any two columns, you will find the value becoming negative 10. That's the property mentioned here. Delta changes in sign only. So let us verify. In this session we will list the property, we will also verify the property as explained in NCERT. Well, so delta we already know 10, because again and again we are coming back to the same determinant. We are not considering any different determinant. Consider the same determinant. Let us interchange any two rows. You can select any two rows. I am going to simply interchange, probably let us say R2. Students are free to do any interchanging. This is the interchanging symbol. R2 goes to R3, R3 comes in position of R2. Done. So now delta, shall I say delta dash? Okay. Property says it will not change, it changes in sign, so I cannot call it by the same name delta. So row 1 has not changed. Row 2 has gone to row 3. Row 3 has come to position of row 2. So 2, 1 and minus 3 is in row 3. 1, 1, 1 comes to row 2. Let us expand, find the value once again. First element into its cofactor, negative 3 minus of 1 again. Then as a cofactor, negative of negative 1. And the minor, once again, minus 3 followed by minus 2. And a plus 1 and its minor 1 minus 2. You can see it is minus 4, minus 5, minus 1. Directly you can see the answer is negative of delta. It happens to be negative 10, which is negative of delta. Magnitude is 10, but changes in sign only. If the sign was earlier negative, this would have become positive, obvious. We'll go to the next property. This is P2, P3. When we come to P3, we find a very striking feature of determinants. Any two rows, when I say rows, all elements of a row, any two rows, of course within bracket column, any two rows or column are identical. What do you mean by identical? As I told you, all elements are identical in the corresponding rows. Any two rows or columns are, I am mentioning the word identical, so that implies the determinant value will be 0. So that gives you a brilliant idea. Whenever you find the two rows or two columns are repeated, having the same elements repeated, we can, without expanding like this by row 1 or row 2 or row 3 or any other means, you can straight away write the answer 0. Let us check it. So I am going to make a delta dash. So maybe I will write third row anyway has 1, 1, 1. Let me make row 1 also 1, 1, 1. and in between I can put the same row 2. Same row 2. Well, let us expand. What happens? First element, the minor of that 1 minus of minus 3 plus 3. Then there is a negative sign for the second cofactor, a position 2 1, and minor happens to be 2 into 1 minus of minus 3. I'm sorry, minus of minus 3. Well, and then the third element 1 into cofactor 2 minus of 1. So we have 4 minus 5 and plus 1, which gives 0. That was the expected answer. That was the expected answer. Any two rows. This can happen with any two columns also. So that is the brilliant feature, property P3. Move on to property P4. When a row completely gets multiplied by any scalar constant, a real quantity, a real number, the whole determinant gets multiplied by the same real number. Okay. So if a row is multiplied by a scalar, I'll call the scalar K, then value of determinant or the value delta is multiplied by the same scalar. So let me write, instead of saying same scalar, I'll write K multiplied by K. Well, let us do it. Consider the given delta, row 1 having 1, minus 1, 1. Second row 2, 1 and minus 3. Third row having 1, 1 and 1. Let me multiply, say, row 2. Row 2, let me multiply by 2. So row 2 I am replacing as 2 times row 2. I am using this symbolic notation, which is the way of representing a row operation. So what happens? Now let me call it delta dash, because it contains different set of numbers. Row 1, 1 minus 1, 1 only. Third row not disturbed. Second row, all numbers are multiplied by 2. Therefore, the entries are 4, 2 and minus 6. 4, 2 and minus 6. Now let us expand. Take the cofactor of the first element, 2 and minus of minus 6. Then second cofactor will change the minus into plus. Minor is 4 into 1, minus of minus 6. Then the last element and cofactor 4 minus of 2. So which gives the answer 8 plus 10 plus 2. You can see 20, which is 2 times of delta, because delta was earlier 10. So we can see we didn't care to multiply all the 9 elements of the determinant, but we have multiplied only one of the rows, and the row is selected. We selected row 2, all elements were multiplied, and we find a different delta appearing, and the value is twice the value of the delta earlier. So it is 20 now. You can see If you multiply all elements in a row, it is sufficient. Entire determinant gets multiplied. The same thing will be true for not only a row, this can work for column also. So it works for column also. How does this help the students? For example, NCERT also gives a very good remark. So the remarkability, where the remark comes is, suppose the original determinant was 2, 4, 2 and minus 6. Or imagine the delta originally is like this: 2, 4, 6, 1, 2, 1, 1, minus 1 and a 0. So you find the row 1 has 3 elements which are all even numbers, which means 2 is a common factor. That means the row 1 is the elements 1, 2 and 3 multiplied by 2. If you make the elements half, you get 1, 2 and 3. Those numbers when multiplied by 2, that's how you get 2, 4 and 6. And if you think the determinant, the row 1, the element 1, 2, 3 has been multiplied by 2, then the entire determinant has been multiplied by 2, whereas the original row 1 will have only 1, 2 and 3, not 2, 4 and 6. Virtually, we are following the converse property. So if the result was 2 delta here, then the original delta you can see is 2, 1 and minus 3 only in row 2. But when you find 4, 2 and minus 6 and 2 as common factor, you can divide by 2, write the 2, 1 and minus 3 and write the 2 outside, because that number 2 multiplies entire determinant. So we can see this is a common factor property. So let me emphasize. Property, this P4 property, students can remember this as a common factor property. From out of a row or from out of a column, if you find divisibility working for the set of all the entries, you can take that divisor as common factor out of the determinant. So what is left over is this. Okay. So you can, students are welcome to evaluate this, to evaluate that and verify the coincidence of the values. All right. So let me stop here. We have come up to P4 and I was able to give you explanation, example working out for every determinant. And the next video, let us go into the remaining property and we'll take up more determinants to prove from NCERT. Thank you, students.